Hello. Welcome to my presentation on challenges testing microservices in distributed systems and with one possible solution. So what do I want you to get out of this session? Most of all, I wanted to get curious. I want you to learn what I felt was necessary to understand why and how we could do testing with microservices in distributed services systems. And I want you to learn enough to go back and maybe start playing with this tool I'm going to show you, which is called WireMock. And if you already played a lot with WireMock, you may not learn that much new, but then you can still look forward to the interactive quiz we're going to have at the end of the talk. So stay tuned, there will be a prize for the winner. My name is Lotte Johansen. I come from Norway. I'm a senior developer at Finn.no. And last year, Finn.no invited Fred George, who is also here, for a workshop on microservices, so I attended that one. So then I got to hear about this conference, and he said, oh, you should send an abstract to this conference, and here I am. Usually when I talk at conferences, I talk about accessibility, which is also something I care about. But I'm mainly a backend Java developer, so today I'm going to talk about testing in distributed systems. Has anyone here heard about Kaleido? Hey, a few hands there. 7 years ago, I was here in Berlin working for 2 months on Kaleido because it was part of the same code base as the Norwegian version we had at home. So they decided to split it up, and then we were training some local developers here in Berlin for a few months. So it used to be part of our whole big monolithic system, but now we've split up in microservices. My company is called Finn.no, and it's the main classified ad site in Norway, an online marketplace. So if you want to buy anything, you go to Finn. And so I'll teach you one Norwegian word today. It's Finn, and it means find. So it's not close to German as well, Finn. So it's used by everyone. If you want to buy a car, you go there. If you want to buy a house, you go there. If you want to buy general merchandise, you go there. And you also, if you want to buy travels, like flights and hotels and cabins, you go there. And it's owned by another company called Schibsted. It used to be newspapers, and then Finn was separated as a classified ad site. And now it's becoming across the whole world. So we're in 29 countries and 7,000 employees. And when we split up Kaleido 7 years ago, it was to concentrate on Norway, but now we're going to work more as the whole world again. So Finn started in 2000, and this is from 2005. Then we had this monolithic system. We had 4 releases a year, and each release lasted for 6 weeks. So we had the 6 weeks test period, and then we had the release, and everything stopped for a whole week when we deployed it into production. And there was little testing, and mostly manually. And this monolithic system was layered architecture, as many people have talked about here. And it was called IAD. It was before iPhone, before iPad, but not before iPod, though. So it's about ads. I started in 2008, and in 2009, they made a new IT strategy that they wanted to move into microservices. They had tried to pull out 2 services at that time. That was the hotel one and the CV one. However, they were still sharing a lot of the same code as the IAD, the monolith. And also they shared the same database. So it was not microservice at all. Our first more close to a microservice was a single sign-on service that came in 2009. That one was divided from the code base. However, it was also sharing the same database. So this was the data model from 2009. It's everything here is this is one code base. Really not a microservice, right?
Could you show the details, please?
So there are some challenges with monoliths, as probably most of you know. If you want to scale one part of it, you have to scale everything. If you want to release just a tiny part of it, you have to release everything. And it's really easy to make spaghetti code because everything is so close by, and it's just to call that method, and it's, yeah. And I remember one of my first days at Finn, I managed to break the code, and then I broke it for everyone. So an email was sent out to all the developers that I had managed to break the code. So that's also something that is better if you have a microservice. You're just working on this tiny service, and if you break it, it's just bad for yourself. And you also have some limitations when it comes to language and architecture, because you have to follow the guidelines for the rest of this monolith. So from 2009 and so on, we tried to pull out what we thought could be separate services. And in 2012, this was one of the first microservices that had its own database and everything. So I was actually the one putting it or deploying it into production here. It's September 2012. It was a vetting system that vetted the ads that go through the system. And now we have more levels. This is our own continuous deployment system. It's called Pipeline. Now we have more systems, more steps here. So we have build and development and test and verification and production and test and production and so on. So today, about 800 verified artifacts every week. So, but that's not the whole thing. We have more deployments every week because each verified artifact leads to several deployments. So there's about 4,000 deployments every week now with our continuous deployment. And as you see here, it's the different numbers of verified artifacts. And the first one is from 2012, and that's one at the bottom. Then there were five verified artifacts, and the week before was 2 verified artifacts. So that was the week when I deployed this vetting tool into production. So one of the first ones that became real. And now this was from last year, the microservices we had. Maybe we're just a distributed monolith because you see there are lots of dependencies still. Maybe we just move the dependencies into runtime. Well, 2 years ago, we started using Hystrix, a circuit breaker made by Netflix. And that made it a whole lot better, because then at least you had to specify what will happen if the other services don't work and if they don't answer. And also we have started using Kafka and message buses, and that's also improved. However, we have a lot of dependencies. This is another description of the dependencies that was just last week. It's the Zipkin, which is a distributed tracing system, so they could show all the connections between your microservices. So there are some challenges with microservices as well. Now just different things go wrong instead of in the monolith systems. So you may have more network issues, and there may be more drop of packages, and you might get slow retrievals, and it's getting more complex. For each connection, you have to go over a network to get, instead of just calling another method. So it's getting more complex, and it's also hard to test. That's what we thought of. So that's what I'm going to talk about today, to how we can do some more testing in distributed systems. I will show you some theory. Maybe you know it already. One of the things I felt was necessary to understand why we should do more testing in distributed systems was these 8 fallacies of distributed systems. It was made as this list in the 90s, first by Peter Dodge and some other people from Sun Microsystems. And when I studied communications technology 15 years ago, we also learned about distributed systems. So this is nothing new, because the telephone systems, they have been distributed for decades. But it's more new to just like normal computer systems that it's more distributed now. But you have had distributed systems for a long time. The first fallacy is that a network is reliable. There might be some road construction which cuts some wires, and then your connection goes down. And also, some people manage to do harm. This woman here was in the news. She's from Georgia, and she managed to cut the whole internet connection from Georgia to Armenia because she thought these wires were made by copper, so she wanted to collect that. So people are able to do pretty much harm as well. And also the animals like to bite on these wires, both under the seas. The sharks think that there's this fish. Oh yeah, I should bite this. So lots of cables have been destroyed by that. So even if you have a good wire, it may be down, and the connection may be down. And we should test this, right? We need to test what happens if our connection goes down. What will happen? Will our service still work if the connection is down? And the second fallacy is that latency is 0. Well, this is a map of submarine cables. You may have also some satellite and ground cables all over. And it takes time both to just pack everything and unpack everything, and then it takes time to transport it. So you may think that the latency should be 0 because it goes so fast, but it takes time to go across the world. Here's some examples. For example, from Sweden to United States, it takes more than 100 milliseconds. And from Sweden to Poland, it takes about 40 milliseconds. And to Argentina, it takes more than 250 milliseconds. And if you want to go to March, it takes about 28 minutes back and forth. But you don't have to think about that unless you're NASA, though. So how can we test that our service works, even if it takes time to connect to other services? And what will happen if the connection times out? We should test that. The third fallacy is that the bandwidth is infinite. Well, data can't flow any faster than the message broker can process it. And if you have this thing in the middle, for example, a database, it will stop everything else if you just have one. And the bandwidth is not infinite. You may add bandwidth, but not infinitely. The fourth fallacy is that the network is secure. Some years ago, there was this heartbleed issue where people were able to try to connect to open SSL servers, and they got some random bits from it. And these bits were close to the authentication code, so they managed to get things out of these servers even if they got denied to the servers. So it's not completely secure. And there are also bad people out there. And there have been lots of incidents where several user accounts have been lost. And eBay had even several million user accounts lost. So the more money your business is worth, the more money the hackers are willing to spend to try to hack your system. So even if you use the best practices, they could manage to hack your system. So you should make a plan for this. What should happen if something is lost? And you should include the PR in your company for that. The fifth fallacy is that the topology doesn't change. Especially now when we have the servers up in the cloud, the topology changes all the time. Servers are added and deleted, and they go up and down all the time. And you may have different data centers. And what happens if the connection in between those data centers is broken? We should test for this, right? What happens when servers go down? Will our system still work? The sixth fallacy is there is one administrator. It's also called the administrator knows what to do. Because it's not true that there's only one. You have lots of administrators. And if you maybe have one at one time that knows a lot, then maybe he gets run over by a truck, or maybe maybe better that he's promoted. And then there will be other people coming, and they won't know everything. And the code base grows, and yeah, you should make tests for this, right? Just to see what is the system actually doing. You should make the test that describes the system, not just a lot of tests. When I started in Finn, some years before that, they had this bonus goal to have a certain amount of tests. And of course, they reached that goal. But then tests, the quality of the tests were not perfect. They were just testing, well, many of them were just testing that Java is doing what Java is supposed to do, and so on. So you should make relevant tests that describes the system so it's easier for the next people to take over your code. The seventh fallacy is that transport cost is zero. In 2014, Netflix paid both Comcast and some telecom providers like AT&T and Verizon to use their networks. Well, it was not to say that this should give them better access, but it was just to share the costs. And it adds up everything also when you send something. It costs to serialize and to deserialize. So that it's zero cost, that's false. And the last fallacy is that the network is homogeneous. Most people, at least programmers and developers, they don't have this fallacy anymore. We see that there are lots of different kinds of networks. You may have a solid fiber connection, or you have Wi-Fi, or you have 3G or 4G or something. You have lots of different types of networks. And also, you have different types of things in the network. It's not only .NET or Java, you have lots of different kinds of systems, and these systems may not even talk to each other. So it's not homogeneous at all. So here's the whole list of distributed systems. And I said that there were 8. After these 8, there has been added a few more. So you could say there are 11 now. The 9th one is that the system is atomic or monolithic. The 9th is that the system is finished. And the 11th is that business logic can and should be centralized. So you have lots of different fallacies that tell us why we need to make tests to make our system work. And we have the 12-factor app. I won't go into all the details here, but this is a description of principles. So if you follow these principles, it will be easier to distribute your services. And a good thing about them, if you follow these principles, is that it also becomes a lot more easy to test. So you should look at these 12-factor app principles. And when I did my testing with WireMock before I came here, I spent a whole lot of time trying to fix things because we were not following all these principles. We had some dependencies that were really hard to get rid of. So we want to test, right? How can we do that? So let's talk more about testing in distributed systems and the tools here. Martin Fowler wrote about this test pyramid by Mike Cohn, which shows the separation of different types of tests on different levels. So on the top here, you have manual exploratory tests, and then you come down to end-to-end tests where you have more automatic tests of the whole system. And then you have component tests that test that one component of different units is working. And then you have integration tests of different integrations between components and units. And then at the bottom you have units, which is just testing one thing, no integration at all. So it describes both the levels of your tests, and it also describes how many tests you should have, how much effort you should put into each level. So you should have a lot more unit tests and very few exploratory manual tests at the top. And we usually use only 3 levels. So you have the unit, and we have this end-to-end, and then we have the component in the middle. There are some testing tools out there. Here is one part of them. We use Mockito just for unit tests, and we also use NOC for NOC servers. And there we have different ones that can stub out HTTP calls. The one I'm going to talk about today is the one in the middle here, called WireMock. I won't say that this one is a whole lot better than the other ones, because I haven't tried them all. But it's one possible solution. So let's talk about WireMock. Our WireMock was originally created in 2001 by Tom Akerhurst. And we used WireMock since last year, so we haven't used it that long. I'll tell you about the tool and give you some examples, and I'll also show you a little demo. So what is WireMock? You can say it's a simulator for HTTP-based APIs. It could also be a service virtualization tool or a mock server. What it does is that it mocks out the the external calls for external services, so that you can concentrate on your service, and then it looks like you get answers from your external servers, but it's just WireMock that answers instead. So it's a stubbing. I think this model describes it pretty well. You have your system in the middle here, and then you set up the Mock server to the right, which is WireMock, and then you create a test, and when your test calls the system, when it gives the external calls, then WireMock will give the responses instead of the external servers. So it's a very good tool to simulate faults and delays. And you can use it either as a library or a standalone process. It uses REST and JSON, and has this JSON interface. So you're not dependent on Java, but you can also use the Java API that they have. So where can we use WireMock? In this test pyramid, we can use it in all the in-between layers here for integration between different services and to check one component. And also, we use it at Finn for end-to-end tests to the external calls, because we have this, you can get cabin offers from different sites to our site, and then to test this, we can test our whole system, and then for the external calls to this, all these cabin sites, we use WireMock, so we don't have to call them during our tests. Here is one example. To the left is the Java version, and then to the right is the same one in JSON. So here you just have one, you say that for this URL something, you want to return response with some hello world. And here you have the same, you have the URL here, and you give the response 200 OK with hello world. And then you can test that this something will give 200 OK, and that's, everything else will just give 404. It doesn't answer anything, you don't specify, because it's a stub. And it's really good to simulate errors. You can say, I want to have this fixed delay of 2,000 milliseconds, for example, here. Or you can just say that you want to give a random delay, and then it will just give some random. And you can make different stubs, and you can set this delay for one stub, or you can put it as a global for all stubs. You can also simulate bad responses, like empty responses, or just malformed responses, or just some the random data and close down. And then you just say it here, I want to give to this URL, I will give a fault with this kind of type. So it's a good way so you can simulate your server or your service, how that will, if it will act if other services give a bad response. Here's the example that I've been testing at my company, because I've been working on some trade system that we make escrow solution, so people can, when they buy something on our website, they can decide that we want to pay to each other in a safe way, and then the money is paid into Finn, and it will be there until the buyer got its product and everything is okay, then the money is transferred from the buyer to the seller. So it's an escrow solution. And this is a very simplified model of it. So we have this trade service here. It's a microservice. And it's the API towards the web and the apps. And then this trade service talks again to the safe payment, which again calls the external payment, and some trade agreement where the buyer and seller agree. So the demo example I'm going to show is the interface between the trade and the safe payment here. And we use something called Siren. Siren is a hypermedia specification for representing entities. When we use this, we can just give the main URL for the service. Then we get the service document. And here we can explain what is allowed to do in this service. And we can have different actions that is possible to do. So in this example, I have two external calls that is called usually to safe payment service. The first one is the service document, and from there, the next one is to start a payment. So these are the two calls that I want to mock. So then I put WireMock in between there. So instead of calling the external service, WireMock will answer these two URLs here. I took a copy of the original service document from the safe payment, and then I changed this URL for start payment inside the service document so that it will be this localhost start payment that WireMock listens to instead. So in my Java code, then it looks more like this, and it's the whole service document where I changed the start payment URL, which is the second URL. So then I create two stubs, one for each of these two calls. So the first one is to get the service document. It should return 200 OK and return the service document. So here's the service document that I showed on the last slide. And then the next is a stub for the start payment. And that one should return some status I want to enter into the test and some return body that I also want to enter into the test. So that's what I give into this test. So I create two stubs. And then I create a WireMock rule. The WireMock rule starts this WireMock server. So it listens to some port. First, we made one port, a specified port. You can do that. But then if you run several WireMocks at the same time, it can crash. So it's better to use this dynamic port that they offer. And then before each test, I find the port and I start the safe payment client that should originally talk to the safe payment, but instead it will now talk to WireMock. And here's a test. It's a real test. It will run. If I won't do it now, I'll just show it here, but it's real code. So here I create the entity that is supposed to be returned. And then I create the two stubs here, and it should return OK, and it should return this entity. And then I start the safe payment client, and I call the start payment there. So that's the code that is run, and this one will call again WireMock. And then I can assert that everything goes all right, we use some functional programming called right for if everything is okay, and left if there is a failure. So here I check that everything is right. And then I can check that the code inside the safe payment client is using the, whatever I want to check. So that's the test for everything is okay. And then I can also test if there is a failure. When I did this testing, I learned more about the system that I knew before, because I thought that I would get a failure in 500. But then that one just gave me an exception, because it was difference between system exception and application exceptions or so. But 428 precondition required, that one gives a failure. So I can test that this one will just give create the stubs that it will return 428. So, yeah. And then I start the safe payment client, and I call it a start payment, and I check that this one gives a left because there is a failure here. And the last one is a 500 exception. Pardon?
The failure is. Okay, I'll speak loudly.
Yeah.
Okay, fine. Failure.
Yeah.
Yeah, is a failure, does it just mean application failure?
Yeah.
Or can it be a system failure, just like a network error? Or what is the exact meaning of failure in these
Here it's
environments?
It's not 500 internal error. That will be an exception.
That will be an exception always, and failure. So failure, it has a meaning in your application domain.
Right.
Okay.
So this one is the last one that gives an exception. So here I create the stubs again, and they should return 500 and empty. And here I can check that when I start it, it will fail and it will throw an exception. So it's a good way to check how your system will react when it talks to other services and they fail in a way. So now I showed you how it works if you have it inside a test and you run everything inside Java. You can also set up WireMock as a standalone process. And now I'll show you that if the demo gods are with me today. So first, I'm going to try to, I'll put a little closer. Okay. First, I'm going to try to call hello conference here. And I won't get any response because I haven't started WireMock yet. So I need to start WireMock. Okay, I just start WireMock by calling. I download the WireMock from the WireMock page. It's a jar file. And then I just started as here and I'll start it here. Yay, it's running. And then I'll try again to call hello conference. And now it gives 404 because I haven't specified that this one should say anything, and WireMock doesn't react to anything. It hasn't been specified. So I need to specify that. So I will here run this curl where I say that if I get hello conference, it should give a response 200 OK and somebody inside of it. Okay, I run it and I'll see again if it works here. Hey, hello microXchg. So that now WireMock is responding to this URL here. So I can either send this as a curl, the request to it, and it will store it. Or I can save it as a JSON in a JSON file, and I save it in inside WireMock. So I already made this JSON file, and I saved it in the mappings file. So now I'm going to call this other URL, which is called API my test, which is what is specified in this JSON file. Oh, I have to take the other one, of course. There you go. WireMock rocks. Yay. So now you can see that you can store JSON. You're not dependent on any Java here, so you can use it anyway just to use JSON towards your WireMock and check your API. So that was my little demo. What is positive about WireMock? Well, it's pretty easy. You can start it right away. It's good documentation on the website, wiremock.org. And it's very good to test, to make tests, and you're not dependent on your external services. So you can simulate failures and delays, and it's a good tool to do that. And then you can have, as I showed you can use it just by using JSON and without any other Java. So it's possible to use it if you don't like Java. And it seems to have a pretty active community, so that's why we chose it. There are some challenges, though. You need the JVM, the Java Virtual Machine. But a colleague of mine, he put up WireMock inside a Docker container, so then it doesn't seem to be, you don't have to think about this JVM at least. Another thing is that the WireMock is only for HTTP and HTTPS. It's not for all types of protocols. So if you have some thrift, or you have, if you want to test other protocols like SMTP or TCP or something, then this is not the tool for it.
Does it support WebSockets?
I don't think so. I'm not sure. Okay, so now we're going to play. You can all find your cell phones, and we're going to go to Kahoot. Has anyone here played Kahoot before? No one? Oh. It's also a Norwegian thing, actually. It's made on Microservices as well. I read that when I made this. So you can all go to kahoot.it, and we're going to play. And there's a prize for the winner I got from the HR department. So there's a nice bottle and some other good stuff. And I added some chocolate as well. So prize for the winner. So go to kahoot.it, and we'll see if everything works here today. Let's see. Ready? Yeah, and the video I'll show you here is from our 10th anniversary at Finn. I'm part of that. It was fun. So join with this game pin here.
Sammen har vi stått på i 10 år. Sammen har vi skapt mulighetenes markedsplass. Vi har lagt butikk, rubrik for rubrik. Vi legger sjela vår i hvert eneste klikk. Vi er Finn.no. Vi er Finn.no. Alt fra vi ikke bare til bowlingkuler. Båter, flyreiser skaffer vi Norges folk. Vi har eiendom, vi har møteplasser. Vi er klart vi jobber på resteplasser. Vi er Finn.no.
Is everyone on there now? Okay, so if nobody else now enters, then we will start in 7 seconds. No, because it's, no one else can enter now. So it will start in 7 seconds. No. If you wanna join and you haven't already joined, then wait till after it starts. Okay. Yay! There's 7 questions here. Hey, most of you got it. Six more questions. Klaus is leading, yay. Changing winner here. Seems like you understand that it's important to be quick. Oh, so many of you thought it was Finland. Okay, the winner is Alexei. Where are you? Can you come up? You can get your prize. Here you go. Congratulations. So to conclude my presentation, we've now seen that how we've gone from a monolith to microservices at Finn, and with some benefits and challenges. And we've seen some theory of why we should do testing in distributed systems, like the 8 fallacies. And then we've seen some testing, and we've seen WireMock and how it works. So what you can do now is to go back. You can go to wiremock.org and you can just start playing. I hope you learned enough to get curious, and I hope you'll get something out of it. So thank you very much for coming.